And then since we are tasked to provide the probability of z less than, so we will select below the z-score. So the mean of a standard normal curve is equal to 0, and it is located along the middle of the curve. Okay, so since our z value is 1.08, it is expected that it is to the right of this mean. Okay, so we move here, so 1.0, okay, this one, and then we have this particular value. Okay, in this video, we will be calculating the associated probabilities of z-scores. Questions are given on the left, and we will start by navigating through the app. We click open the app. Next, we click this menu over here, and then search for p-value, since we want to calculate the p-value of the z-scores. Select this calculator. In this section, we are tasked to provide three inputs. Number one, which area would we like to calculate? Number two is to provide the z-score value or z-score values, which we will see later, and then the significance level alpha. We'll be able to understand how to fill these values through an example. So first, let's solve the first question. What is the probability of z less than 1.08? So we click this drop-down menu over here, and then since we are tasked to provide the probability of z less than, so we will select below the z-score. So we can see here that the symbol z is less than the given z-score value, which is z of x. So we select this one, and then we input the value of our z-score, which is 1.08. And then for the significance level alpha, you might be wondering, there is no given value. So we'll just input. We'll be able to understand this one on the solution that will follow. Now that we have already provided the three inputs that are needed from us, we are now ready to click this calculate button and watch and add to unlock the solution. We are now presented with the solution. First, we list the given values. So here we see that we are given the following information, that z is equal to 1.08, and we are to calculate the area below z is equal to 1.08. So step 2, we try to visualize the required area by shading the corresponding region of the normal curve. Okay, so here it is. So the mean of a standard normal curve is equal to 0, and it is located along the middle of the curve. So since our z value is 1.08, it is expected that it is to the right of this mean. And to the left of that, the shaded region, this purple section over here, is actually our p-value that we are tasked to calculate. So next, for step 3, we determine the p-value of the shaded region. Now to do that, we need to split 1.08 into two parts, 1.0 and 0.08. So basically, if we add these two numbers, we will still get the 1.08. Now, the reason we split this value into two is for us to be able to use a z-table to determine the probability value. Okay, so if we go down here, since the given z value is positive 1.08, we use the positive z-table. And first, we look for 1.0 in the first column of this table. So here we try to locate 1.0, which is over here. So we have 1.0 over here, and next we locate the 0.08 in the first row of this table. So we move here, so 1.0, okay, this one, and then we have this particular value, okay. So this is the probability to the left of z is equal to 1.08. So here this is the 0.08, and this is where they intersect. It's easier to locate the value of this z table because of this line. So as we can see here, 1.0 is below the line, okay, the first value below the line. So once we find 0.08, here 0.08, so this is the intersection, and this is our p-value. So going back, we have p is equal to 0.8599. Now for the optional step, step 4, formulate the conclusion. This is the reason why one of the three inputs a while ago is the significance level alpha. So basically, we compare the p-value that we have determined earlier to the significance level. Once the p-value is less than the significance level alpha, then the result is statistically significant. In other words, we reject the null hypothesis. Otherwise, if the p-value is greater than the significance level alpha, then the result is not statistically significant and we fail to reject the null hypothesis. So in this case, since the p-value is 0.8559, which is greater than the significance level of 0.05, then the result is not statistically significant. Therefore, the probability of z less than 1.08 is equal to 0.8559. Now to answer the next questions, we go back to the calculator. Now for the second question, we are tasked to calculate the probability of z greater than 2.18. Okay, so here we select on the drop-down menu above the z-score. Z is greater than z of x. Okay, and then we input the value of z of x as 2.18. Same, the significance level is still 0.05 since we are just concerned with the indicated probability. Okay, so we click calculate. So this is the required p-value. And then we determine that that value, this is equal to 0.0146. Now for the next one, we're tasked to calculate the probability value between 1.08 and 2.18. So we go back to the calculator. And then since this is between two z-scores, so it is in this format, z lower, z higher. So we input the lower z-score value, which is 1.08, and then the higher z-score value, which is 2.18. And then we determine the value to be equal to, okay, this one, 0.1255. Okay, it's equal to 0.1255. Now, what's notable in this particular solution is that we have two z-scores, okay, a z lower and a z upper value. And we can actually observe that in the visualization part. So the required area is between z is equal to 1.08 and z is equal to 2.18. To determine the area in between these two z-scores, we have to determine the area to the left of two z-scores, to the left of 2.18 and to the left of 1.08. And then we subtract the two values. Okay, we subtract the probability to the left of the lower z-score value from the probability to the left of the higher z-score value. We get the required probability, which is 0.1255. Now for the last indicated probability, we are to calculate the probability that is less than 1.08 and also greater than 2.18. So in this case, we're trying to calculate the probability outside of two z-scores. So it's still the same, 1.08, 2.18. Okay, so we press calculate. So we have here the shaded region, the visualization of the required probability. And then we have this particular value. The required probability is equal to 0.8745. So basically what happened here is we subtracted the area in between the two values. Okay, we subtracted it from the total probability under a normal curve of 1. Okay, so 1 minus the area between the two z-scores, that would be the result, 0.8745. All right, so we are now ready to solve the challenge question. The challenge question goes, the mean amount of time it takes a kidney stone to pass is 16 days with a standard deviation of 6 days. Suppose that one individual is randomly chosen. Let x be equal to the time to pass the kidney stone. Round all answers to 4 decimal places as possible. Find the probability that a randomly selected person with a kidney stone will take longer than 15 days to pass it. Now, to solve this question, we go back, and then instead of directly calculating the p-value, we still need to calculate the equivalent z-score value of the particular patient. Okay, so in this case, we go to the z-score calculator. So this one, and then we try to input the given values. So it says in the problem, find the probability that a randomly selected person with a kidney stone will take longer than 15 days. And we are told that the population mean is actually equal to 16 days with a standard deviation of 6 days. So now we try to calculate this one. Okay, so here we have the given values. X is equal to 15, mu is equal to 16, population standard deviation is equal to 6. Now we calculate the z-score value using this particular formula. Okay, so we have 15 minus 16, okay, divided by the population standard deviation, which is 6. So we have negative 1 over 6, or convert that to decimal, it's negative 0.1666666. And we round that off to 2 decimal places. So the reason for this is that we will be using a z-table later on to calculate the p-value. Okay, so we go back to the calculator. Okay, so we have p-value of a z-score. Okay, and since we are told that it will take longer than 15 days to pass it, so we will try to calculate the probability above the z-score. Okay, so it will be greater than the z-score value of negative 0.17. So we now calculate, we have the following answer. A randomly selected person with a kidney stone will take longer than 15 days to pass it is equal to 0.5675. So this is, if you find this video helpful, please leave it a thumbs up. Subscribe to this channel if you are not yet subscribed, and ring the notification bell so that you will be updated on our latest uploads. And as always, I'll see you on the next one.